Hi, my name is Nisal Pereira. I'm a senior machine learning engineer at Expedia. Today, I'll be presenting a reference architecture for a real-time end-to-end recommendation system based on Google Cloud Platform. I'll be utilizing Google's Vertex AI throughout my system design. Let's get started with the problem statement. So we are a large e-commerce platform with tens of millions of monthly active users, and we are tasked with designing an end-to-end real-time machine learning system to generate recommendations as the users browse the website or the mobile app. We need to generate these recommendations in real time as the users interact with the site, and we want to have a ultra low latency of around 100 milliseconds, and we need to be able to retrain these models to adapt to latest trends and use the latest data. The system should be able to detect data drift and model degradation over time and adjust accordingly. And this has to be highly scalable, serving from hundreds of queries per second to thousands of queries without any hiccups. So here are basic design goals that we are trying to achieve. We need to have ultra low latency, generating recommendations in real time with highly scalable and resilient infrastructure utilizing Google's cloud services. And we need to use state of the art scalable machine learning models for recommendations, which I'll go into bit detail in my system design diagram. The system has to be auditable and reproducible. The system should have monitoring and alerts and should consider ease of maintenance in the long term, as well as we need to adhere to the highest level of privacy and security standards. And we need to achieve all of this while minimizing overall cost of the system. So here's the system diagram that I came up with to solve this problem. Let me walk you guys through it. So it starts with collecting the raw data, which are like users' clicks and interactions on the website. This data is sent to an API gateway, and we have click ingestion service. Basically, this is a PubSub IO service on Google Cloud Platform that writes this data to PubSub queue, later read by process click system that is basically a data flow a workflow. And in this PubSub, we have multiple topics like the clicks, purchases, and browsing. So the click ingestion service can write to different topics, and the process clicks can read from this PubSub and write the data to the Google Cloud storage for long-term storage. The reason we have divided into different topics is for scalability. We can also divide it by different regions and different products, etc., to make it highly scalable, and we can horizontally scale as we get more data and as we introduce new streams of data that we need to capture. System basically has two interaction endpoints. One is pushing the clicks and the browsing data from the user side into the system, and this data will be read by Google Cloud Dataflow to do further processing, such as generating sessions and monitoring metrics, etc. The second endpoint that the system supports is get recommendations, where we pass in a user ID and maybe like the browser session, and our recommendation service generates recommendations for this user in real time and returns to the user under 100 milliseconds. This recommendation service could be running on like Google Cloud Platform managed Kubernetes service like GKE. So this is horizontally scalable as the changes in the traffic happens, which is one of the requirements. Let's dive a bit into the model architecture that we'll be supporting. So as I said, we want to use kind of a state-of-the-art recommendation model. And most state-of-the-art systems are currently based on this two-tower model architecture. One is retrieving user and product embeddings, basically using nearest neighbor algorithms to generate candidate products, and then doing a second level of ranking or filtering and applying any other business logic on top of these retrieved products. That will be handled by the recommendation service. So as I said, once we have this clickstream data coming into the Google Cloud storage, we want to generate these vector embeddings that will be used by the recommendation service to generate the candidate products for the recommendation. So we have this feature engineering flow. This could be like a Google Cloud Data Flow or like a Spark job that reads data from Google Cloud Storage and do this feature engineering, basically generating these vector embeddings and write them to the offline feature store. It could be Vertex AI feature store or BigQuery. And this is our offline feature store. And every hour we have another job that reads this data from the offline feature store and push them to the online feature store. In that way, we can make sure that our recommendation service has the most up-to-date data when it look up feature embeddings from the feature store. And these feature store include things like these vector embeddings for users, items, as well as users' historical features, purchases, and any other information that the model needs to generate the recommendations. So once we have the recommendation service, we will move on to the monitoring aspect of the system. Every time the model generates recommended data will be piped to a model monitoring service. We'll be using TextAI's model monitoring service for this. And this will continuously monitor the model's performance. So this model monitoring service will continuously monitor the recommendation service, the predictions generated by the model, as well as the data that was sent to the model, and detect model degradation as well as data drift, and make necessary calls to the model update service or model retraining based on certain rules that we can set up. For example, it might decide to roll back kind of the latest version of the model if it detects it has degraded performance, or it might trigger a retraining of the model where the model will be updated with the latest training data coming from Google Cloud Storage, as well as the features coming from the offline feature store. And we'll be using Vertex AI pipelines for this model retraining service. So this service has multiple steps. It can do like data pre-processing, model training, and also do model evaluation. And it will generate the model artifact that will be sent to the model registry. So we'll be using Vertex AI's model registry. This is important because we want to be able to audit these models. For example, which version of the data and which set of features were used to train this model that is currently in production. So this helps with managing model lineage as well as adhering to kind of the privacy and reproducibility requirements of this system. So once the models are in the model registry, we'll be using the model update service, which will be utilizing Vertex AI endpoints to do rollout of new updates to the recommendation service. This can include things like doing A/B testing, rolling out new version of the model, as well as managing any updates that's done to the recommendation service itself. So for this online feature store, we have two options. So we can either use Vertex AI's built-in feature store, which I believe supports the vector embeddings, vector search, which is kind of the search mechanism we'll be using. And also we have the option of using Cloud Memstore and in-memory Redis cluster as our online feature store. This will be based on kind of the cost and the performance needs. We are able to achieve under 10 millisecond lookup, basically real-time lookup of these candidate product embeddings search. And as you can see, we can use Cloud Composite to basically decide whether we want to run these systems hourly, daily, or so on. What is the cadence of updates that we need to adhere? And we are using the model registry and Vertex AI's feature store for auditing and reproducibility tasks. Google Cloud Storage will be the primary storage. We will have the product catalog data, user click events, purchase history. All the data will be stored in Google Cloud Storage for long term, maybe up to 30 days or 3 months, and the data will be automatically deleted from the cloud storage. Just to recap, what are the Google services that we'll be utilizing? For serving, we are using Vertex AI prediction endpoints and GKE. And for model training, we are using Vertex AI pipeline, query, feature store from Google Vertex AI feature store. We'll use Cloud Composer for orchestration, and for stream processing, we'll be using PubSub with Google Dataflow. And for monitoring, for system monitoring, we'll be using Cloud Monitoring and Cloud Logging on GCP. And for model monitoring, we'll be using Vertex AI model monitoring tool. For CI/CD, we use Cloud Build, GitHub, and Model Registry. And for experiment tracking, we'll be using Vertex AI experiments. So there are things I would like to dig a little bit more deep. These are things like how this system protects the privacy and safety of the users. How do we manage the ML lifecycle, and how we can automate some of these tasks? How do we do multi-region setup where we have test, prod, and pre-prod deployments? And how do we set up system monitoring, alerts on Slack, for example? And how do we extend this system to support maybe AI agents in the future? And what kind of data formats, API protocols we should use when we are integrating this system all together. And how do we handle extreme cases where we have surges in traffic, for example, on Black Friday, how this system can be scaled to handle these cases, as well as larger system integration. Maybe we want to use these recommendations for email marketing campaigns. Maybe we want to use this recommendation with like search and filtering personalization. We can cover these topics later. Other topics that I would like to discuss is things like cold start. Basically, this is notorious problem in recommendation systems. How this system can handle cold start. Basically, how do we recommend products to users when the user doesn't have any history, or the products that doesn't have any information available at the prediction time? And also, how do we gracefully handle failures? What are the guardrails and fallback mechanisms we need to implement so this system doesn't fail for any reason? And how do we integrate this system with the user interface? What is recommendations going to look like from the UI side? And how we can improve the user's experience using these recommendations? And what are the KPIs we need to track, whether it's are we optimizing for clicks, purchases, or the time spent on the site? So these are the metrics that machine learning engineer will have to work with the data scientists to come up with. And also, how do we do A/B testing, and how do we use interleaving, which is kind of the state of the art A/B testing framework used by Netflix to rank their recommendations on the platform, and multi-arm bandit approach, where how do we double down on experiments that are working, and how to solve kind of the explore versus paradigm where we want to explore new algorithms as well as double down on models that are working. And also, how do we extend this system to handle multimodal input, like could be images, could be audio? How do you integrate that data into the system and extend this system to support this data format? I'm happy to have a conversation and go over any of these topics. Looking forward to talk to you guys. Thank you.